Boleh tak?
Boleh doktor.
Clear tak sebenarnya? Saya cakap dengan kekuatan sebegini.
Ya doktor.
Okey, doktor.
Doktor.
Kalau tak clear kena bagi tahu
Okey doktor.
Alright. Okey kelas. Sebelum tu macam biasa untuk mulakan kelas ni supaya internet tu agak okey. Tak tak ada sangkut-sangkut, saya off my camera
Okey doktor.
Boleh nampak?
Nampak doktor.
Okay, alright. Okay, so last week kita dah pergi kepada separable ODE. Okay. We went through about what is separable, how we can identify that equation or that function, we can use separable equation or not. And then we go few examples and also exercises. Okay, now we continue. We continue for the next method for solving first order ordinary differential equation. Okay, so the second method. Yeah, I'm trying to record. Okay, just started. Okay. So we look at the next technique. Okay. In order to solve ordinary differential equation. So it is homogeneous, homogeneous ODE. Okay. So homogeneous ODE. Okay. About definition, what is homogeneous? Okay. An ODE is called homogeneous or homogeneous ODE if it can be arranged in form of your differential equation dy dx equal to fxy. Okay. You have an equation, a function. Okay. Similar if you add this lambda to the equation for x and y. So lambda here is a real number. So class, meaning that if a function or an equation, okay, you need to substitute or you need to replace your x become lambda x, your y become lambda y. Okay, and then you compare these two equations or these two functions. Okay, if it is tally, so that equation is called as homogeneous equation. Right. So there are few steps, few steps for to solve homogeneous ODE. Okay. The first condition, it must be homogeneous equation. After you check the equation homogeneous or homogen, okay, so you can go to the next steps. So The first one, you need, okay, of course, you need to, as what I just explained, okay, x become lambda x and y become lambda y. So it shows that it is homogeneous equation. And step number 2, you need substitute y equal to vx. Okay. And dy become dy dx become v plus x dv over dx by using product rule. Okay. After that, step number 3, you need to solve homogeneous equation by using method of separation. So method of separation of variables here, okay, is the method that we have learned last week. Okay. And then step number 4, you need to substitute back v. Just now we have y equal to vx. And then step number 4, you need to substitute back your v become y over x. And then finally, for the last step, you need to apply initial condition if given. Okay. Now, we look at example 1.5, right? So for this example, we have a equal to dy over dx equal, we have dx equal to x squared plus y squared over xy. The first one, okay, before that, I would like to summarize about the step for ODE. Sorry, homogeneous ODE. Okay, so homogeneous okay. So you need to ensure that your dy over dx equal to fxy must be equal to lambda f lambda x, lambda y. Okay, right? With lambda equal to, lambda is a real number. Okay, so steps here. The first one, you need to check whether the equation given is homogeneous or non-homogeneous. How to check? You need to substitute or replace x equal to lambda x, y equal to lambda y. Okay. The second step, you need to substitute. What you need to substitute here? Y, okay, equal to this is a vx. So dy over dx equal to v plus x dv plus, not du, this is v over dx. Okay. The third one, you need to solve by using separation variable. So by using separation variable, okay, separation variable itself, okay, it has its own steps. So the first one, you need to separate. What you need to separate? Okay, x and y. Okay, and then after that, you need to integrate. See, remember, you need to integrate both sides. Okay. Step number 4, you need to substitute back your v just now that you substitute before. You need to substitute again your v into y over x, and then step number 5, you need to apply your initial condition if it is applicable. right? Okay. So we go to the example. First example. Okay. The first one, you need to check whether the equation is homogeneous or non-homogeneous. Given in the question, okay, so this is the equation. Dy dx equal to x squared plus y squared over xy. Okay, this is fxy. Okay, how can we get f lambda x, lambda y? Okay, you need to change your x become lambda x, lambda x. Okay, your y become lambda y. Right. So this is your x squared, this is y, this is x, this is y. And then after that, you factorize your lambda. Factorize, So x squared plus y squared over lambda squared xy. So here, what you can see, okay, this is your lambda, fxy. This is your fxy. Okay. Even if you replace your x with lambda x, in the end, you will get this fxy. But because this is factorized by lambda, so this shows that f xy just now is equal to f lambda x lambda y. Do you have any question? Okay, same with this. Because we get this fxy back. Okay, thank you. Thus, this is a homogeneous equation with degree of lambda equal to 2. Right. So the next step, substitute y equal to vx. And dy dx become v plus x dv over dx. This is mandatory. These two are mandatory. Okay. So we have just now we have dy over dx equal to x square plus y square over xy, so that dy dx here you substitute become v plus x dv dx equal to, so x squared just leave it as x squared, and then now y squared become, because you have y equal to vx, so become vx squared x, and then this is your y. Okay. Then after that, you move v to the right, become negative v. So what we have left here, x dv dx equal to x squared plus vx squared over x vx minus v. Okay. And then we can simplify by, okay, here we have So that is become x dv dx equal to x square 1 plus v square over x squared v. Right. So that you can cancel out this x squared. Then this. After that, you will get x dv dx equal to 1 plus v squared over v minus v. Semua ni tulis balik tak?
Tulis Doktor.
Okay, so saya go slower Nanti you tak perasan.
Boleh, Doktor.
Okay. If I go too fast, please slower down me. Okay. So here, v just now, we multiply with v over v. Why? Because we want to get the same denominator because this is over v minus v. So times v over v meaning that times 1. So that you can have x dv over dx equal to 1 plus v squared minus v squared over v. And then you can cancel this out. You will get 1 over v. So step number 3, solve by the method of separation of variables. Separation variables here. Okay. Step 1, separate x and y. After that, you go for integration both sides. So you separate. Just now we have x dv dx. So what is the key point here? If you still remember, which one should you write correctly? Whether you use x over dx equal to 1 over v dv or like this. Yeah, number 1, number 2. Which one?
Number 2.
Why? Why we cannot write as number 1?
Sebab dx kena ada kat atas.
Yes. Dx and dv must be above here. Okay. Okay, meaning that you all really understood what we have learned last week. Congratulations. Okay. So we move your dv or dx, put it on the top side. Okay, right now we then get v dv equal to 1 over x dx. Okay, this is 1 over x dx. Okay, and then you need to integrate. Okay, integrate both sides. So integrate, you integrate v become v squared over 2. Okay, and then you integrate 1 over x become ln x again plus c. Then step number 4, substitute back your v equal to y over x. So just now we have a v squared over 2 equal to ln x plus c. So V, you need to substitute back as y over x squared over 2 equal to ln x plus c. So this become y squared over x. You put it down, x squared 2 equal to ln x plus c. Okay, this is simple maths, but sometimes even if it is simple, sometimes we can still make mistake. Okay. So we go to the next. Oh, this is example 1.5. A. Signature steps. Okay. So then finally you got this is the answer. Okay. If you try to put your answer like 2x squared ln x plus c also can. But this one must be like this. Okay. Okay, then we go to the next example. Okay, B. Dy over dx equal to y over x minus cosecant y over x. Okay. So step number 1. This is the equation given in the question. This is fyx. So what you need to do for the first step, okay, y become lambda y and then x become lambda x. So, okay, so by having this, meaning that here you can cancel. After you cancel your lambda, you can get like the original one, and then negative cosecant where you cancel this, you will get fx. So this shows that this equation is a homogeneous equation. How about the degree? So the degree of lambda is equal to 1. So step number 2, substitute V equal to y over x and dy dx equal to v plus x dv over dx. Okay, class, if you look at the step number 2 here, y equal to vx, it is actually same as v equal to y over x. So it is not a big problem here, okay? Because you can play around with this equation. So if you look at here, v equal to y over x. Right. Boleh. So because this is just the same, if you change y equal to x, y equal to vx over x, still you can get v here. Sama je.
Doktor.
Mm-mm.
Yang statement degree of lambda tu bagaimana state ke?
based on this step ni, dia kena state jugalah. Tapi sebenarnya this is not very important. Okay. Based
Okay,
on the
Doktor.
steps, kena state juga. If you want to have a very simple one, you just state lambda equal to 1. That's it. Degree lah. Must be degree of lambda equal to 1. Okay. No need. If you have no time, no need to write this long statement. Just state degree of lambda equal to 1. Padam saya tak boleh padam ni. Internet very slow. Right? So you have dy over dx. dy over dx. You have dy over dx equal to y over x minus cosecant y over x. So dy dx you change it to this part. Okay. Sama je. Plus it put behind. Okay. Y over x equal to v cosecant y over x equal to cosecant v. So that what's left? Then you move v go to the right, so v minus v you can cancel out as of 0, and then become x dv over dx equal to negative cosecant v. We go to step number 3. Okay, so solve by the method of separation variables. The first you need to what? Separate. Okay, you need to separate. Okay, how can we get negative sign? Okay. Sin theta equal to 1 over cosecant theta. So this part tests you about trigonometry. Okay. Since we have cosecant and then negative, so when we put it to the left, negative, because it's v, so negative 1 over cosecant v dv equal to 1 over x dx. Right, 1 over cosecant v equal to sin v dv equal to 1 over x dx. The next part, the first step, you need to separate. So in this case, we don't have x and y, but we just have a v and x. So separate v, x. After that, integrate both sides. Okay. So integration of sin v, integration of sin theta d theta equal to negative cos theta. So that's why sin here become positive cos. So integration of, on your right hand side, integration over x become ln x plus c. Okay, ln x plus c we also can call as ln c because it's a function, a constant function, and then equal to ln cx. Okay. So here V equal to, so we just want in form of V. So V equal to cos, you bring to the right, become arc cos. Arc cos, cos -1 ln Cx. So the last step, you need to substitute back V equal to Y over X. So you have V equal to Y over X. So from V equal to cos ln Cx. So Y over X equal to cos ln Cx. And then Y equal to X cos ln Cx. Okay. Okay, do you have any question?
Doctor. Doctor.
Yeah.
Okay. What if we did not change the sine theta, the negative cosec v into 1 over sine theta?
Cos -1.
Uh, no,
Which one? Which one? Sekejap,
uh,
pula.
sine
Step
theta
number 3
itu
or step number 4?
step number 2.
Step number 2. Okay. Step number 2 here. Okay. Here.
What if we did not change the negative 1 over negative cosec v?
You need to talk slowly, one by one, because
Sorry. Okay,
because
what
it's
if
like macam what we call it, not equal tau dia.
aku tak
Dengar
kuat sangat?
tak dengar on off.
Sekarang dengar tak?
Hello.
Hello.
One by one, okay.
Doktor.
Why?
At the
Why
step.
step 2?
Okay. What if we did not change the negative cosec v?
Okay, cosec V into
Okay. Into 1 over sine.
1 over
Yeah.
sine.
The identity, right?
Yes.
What if
Okay. Okay. Meaning that why we just change negative cosec. Okay. You can do it. Okay. For example, we try to use blue color. Meaning that you try to change x dv over dx equal to, so negative 1 over sine v. Am I right?
yes, betul. Yes.
Betul okay. You can do it like this also. Okay. So that you just change, you can do it like this. Okay, so become sine v equal to negative 1 over x dx. The same thing. Dapat tak yang sama? Same thing, right?
So, doktor maksudnya it is compulsory lah to change the negative cosec to 1 over sine v.
Compulsory.
Oh.
Compulsory, but you can use both ways. Both ways are correct.
Okay.
Before that, siapa Muhammad apa yang saya tak perasan? Am I answer your question?
Yes, betul.
It is like, for example, you have equation 1 plus 2 plus 1 plus 2 minus boleh sekali minus 15. Okay, you can start. This is not include about multiply and division. So this is, for example, you have quotient plus and minus here. So you can start 1 plus 2 minus 15 berapa? Let's say 4 here lah. So minus 15 become minus 10. Or you can also start with negative 15 plus 4 plus 1 equal to minus 10 also. It's the same thing. Okay, you can use, you can rearrange your maths. In this case, from left to the right and paling besar. Okay, sama. You can use any method. Sama je. Okay, because I sign V, but it is compulsory. Okay, to change cosec to sin, because a sin trigo much more simpler than cosec. Okay. Right. For example, here in your calculator, do you have cosecant in your calculator? Ada tak cosec? Saya tak jumpa. In your calculator, for example, in the end of the question, okay, you need to find what is the cost and so on. But in your calculator, we have no cosecant. Betul tak? Tengoklah
Betul,
calculator.
Betul.
Gitulah. Logically-nya begitulah. Okay? Ambil yang simplest trigo kalau kita dapat. Okay, kelas. We go. Saya rasa kelas kita dah
Madam.
bersyukur ni. Ya.
Madam,
Yes.
yang ln X plus C tu, kenapa C tu
Mm-mm.
tiba-tiba ada ln C, jadi ln C?
Okay, yang ini in term of kalau kata law ni, dia C is what we call it much like still a constant tau. Okay, still a
Yeah.
constant. So we can change it to ln lah.
Means,
What we have details, kalau nak details lagi macam mana datang tu nanti saya kena check balik. Ln ni dia log of exponential become ln. Betul tak? Log of exponential become ln.
tapi dia untuk contoh soalan yang ada, maksudnya kenapa dia tiba-tiba keluar ln C tu, madam? Dia, ya asal tu ln X plus C dia bukan kurungan kan, maksudnya ln X tu untuk X saja dan C tu constant kan?
Mm-mm.
So
Okay, kalau
yang
kata log, okay, lepas tu?
lepas kita, kenapa dia C tu tiba-tiba dia keluar ln satu? Maksudnya mana datangnya ln tu?
Okay. Wait, kalau nanti kalau saya ni ingat-ingat lupa, tapi nanti saya boleh confirm, saya akan confirmkan semula, tetapi log ln adalah log exponential. Okay, log exponential X become ln X. Kalau kata log exponential C, ln C kan. So, kenapa dia terus ln nanti saya confirmkan balik. Dia sebut log ln, saya takut salah pula. Nanti terus terlekat dalam kepala you all for this part kan. Kalau guna calculator dapat tak? Saya pun tak recheck. Nanti saya takut salah. You all nanti kan lekat terus dalam kepala. Alright? Okay,
Okay.
nanti saya check ni. Okay, thank you for
Okay, thank you,
your
madam.
question. So, exercise 1C. Can we go to the first exercise?
Yes.
Okay. Kita pergi A. Question 1A. Buat dulu. Nak tengok steps tak? Tengok saya kasih step saya. Lebih ringkas bagi saya. Soalan dah salin tak? Sudah. Salin dulu soalan ni. Y prime equal to Y plus X over X. Ten minutes. 10 minutes. Okay. So the answer actually given in the module. So the answer is y equal to x ln cx. Right? So the step homogeneous, okay? 10 minutes. Okay, dah okey ke semua? Dapat tak jawapan?
Dapat,
Jawapan
madam.
dia apa, doktor?
Ha?
Jawapan dia? Oh, okey, dapat.
Dapat
Dapat.
Perlu saya tunjuk ke tak?
Doktor.
Perlu.
So untuk ni solution A. Example exercise apa? Exercise 1D. Let me find it. Okay. 1D question number 1. Okay. Solve the following. 1D ke 1C?
Doktor.
1C. Salah. Okay, 1C. So 1C Q1. Calculate every solution Y of the homogeneous equation. Okay, Y prime equal to Y plus X over X. So, solution dia, first step apa? First step, ya. Tadi, check for homogeneous atau tak kan? So, whether it is homogeneous. Okay. So, kita ada Y prime. So, Y prime kita ialah dy over dx equal to y plus x over x. Ini adalah fxy. Then kita check f lambda x, lambda y equal to. So lambda y plus lambda x over lambda x lah. So lambda boleh y plus x over lambda x. So kat sini f lambda x lambda y. Okay. Sama dengan fxy. So it shows this is homogeneous equation. So degree of lambda equal to 1. Kemudian 1 ke 2 1 Okay, kemudian next be second step substitute. So kalau kita ada substitute x y equal to vx vx dy dx equal to v plus dv dx. So dy dx kita ada dy dx tadi. So dy dx kita gantikan v plus dv over dx equal to y vx plus x over y pula x, biarkan x. So that equal to, so x kita boleh cancel kan? So here x v plus 1 over x. So kita boleh cancel out. So dv over dx equal to v plus 1 minus v. So ni kosong. So dv equal to dx. Betul ke?
Madam,
Ya.
yang dekat substitute tu, dy dx kan, sama dengan v tambah dv dx ke v tambah x dv dx?
Ada tertinggal Oh, ada x. Okay, ada x. Terima kasih. Okay lah, you all alert. X. dx dv dx. X dv dx. Okay. So ada, it has x here. So 1 over x lah You all sama tak dengan saya ni?
Sama doktor.
By dv and then next step. Tadi dv, from tadi kita ada dv equal to 1 over x dx tadi. After that, integrate dv equal to integration 1 over x dx. Okay, so integration v dv become v ln x plus c so v equal to ln x plus ln c. Okay, nanti yang ni saya akan clearkan balik v equal to ln cx. Make sure ini So v next step substitute back v equal to y over x. So kita ada tadi v equal to ln cx. V equal to y over x equal to ln cx. So y equal to x ln cx. Okay. Right. Semua sama dapat jawapan. Okay. So maybe we can go to the next. Okay. Linear ODE. Okay. So saya nak pergi pada linear. Linear not bad juga. Dia punya ni quite simple. Okay. Linear ODE. So kita break 5 minutes. Okay. Ni 12 jam saya 12.05, 12.10. Kita start with
Baik, Doktor.
linear
Okay, Doktor.
sorry kelas, terlalu lama pula. Okay. Right. Okay. Now we continue about linear linear ODE. So linear ODE it is called equation, an ODE equation. Okay? It is called it can be solved using linear when the equation can be formed, okay, in this kind of formation. It has dy dx and then px, it has y here and then it has function of x. Okay. So working steps, okay, in solving linear ODE. The first step number 1, it is need to be written in a standard form of linear ODE. Okay, macam inilah. This is the standard for linear ODE. Then step number 2, you need to find integrating factor, okay, which is I equal to exponential, okay, exponential integration of px dx. The third step, you need to use formula y dot product with I equal to integration qx dot I dx. Finally, you apply its initial condition. So I prefer to write back. Okay. About linear ODE. So first one. Okay. Condition. Okay. Linear. Linear if it is can be written in form of dy dx plus px y equal to qx. Okay. And then the steps here, the first one, okay, write standard in standard form, which is dy dx plus px y equal to qx. Number 2, apa ayat depan dia tadi? Find integrating factor. Integrating factor, so tak apalah. I equal to exponential of integration px dx. Third step, y dot I equal to integration qx dot I dx. Yeah. If you look at here, this one exponential p, integration q. Okay. And then apply initial condition. Yep. Benar. So example, calculate general solution of y prime equal to y over x plus 1. Saya tak baca, saya kena berapa? 17. Hopefully sempat. Okay. Alright. Linear form. Linear form meaning that you need to write in form of this. Okay. So dy dx px. So the question, it has this form dy over dx equal to y over x plus 1. Okay. So in standard form dy dx means standard form. This one standard form dy dx plus px y equal to qx. Okay. So that here, okay, we look at our left hand side, we have dy dx, okay, and then plus pxy. The most important is you need to have y here. So look at the equation. So in the equation, y on our right hand side. So this y we need to move it to the left. So once we move it to the left, dy dx so become minus y over x equal to, so qx we can leave it whatever we have left on right hand side. So here, so that we know that we have y and then 1 over x become our px. But make sure, okay, you look at the sign. Sign here is negative. Standard one is positive. So your px is 1 over x and then the sign is negative. So that the answer is px equal to negative 1 over x. And then qx, what we have on your right hand side? 1. Okay. So integrating factor. Integrating factor is I equal to, okay, exponential I equal to exponential integration px dx. So before we go for the whole I here, so we need to solve for integration so that it is called as integrating factor. So integrating factor here, integration px dx. So just now we have px equal to 1 over x negative. So integrate px dx integration of 1 over x ln x. So you can also write as ln x to the power of negative 1. Okay. Then I equal to exponential ln x negative. Okay, class, here you don't do not need to put plus c for integrating factor. Okay. You don't have to put this for integrating factor. Okay. So exponential ln x negative 1 equal to x negative 1 equal to 1 over x. Then the next you need to calculate y dot I equal to integration qx. This time is qx dot I dx. So just now we have qx equal to 1. So y dot I equal to integration 1 dot, your I is 1 over x dx. So you got ln x plus ln c, so become ln cx. Then y equal to x ln cx. Okay. So we go example 1.7. Okay, class. I want you to try example 1.7 because this part sekejap, stop. Okay. Right. Bateri saya 15 by 6% biasanya tertutup sendiri, so saya nak spare for our next class. Okay. So example 1.7, this is the question you can try yourself, and then we discuss after this. And then for section 8, section 9 we will discuss on Thursday. Okay, for your information, normally I will face to face normally. Okay, I will discuss what I've been discussed in earlier section. For example, at section 8, I will also discuss the same with the same to the section number 9. However, this is online session. Okay, so that what we have discussed for section 8, after that I will bring also to section 9, but my notes, okay, I will share after complete section 9 session. Okay, meaning that saya akan share on Thursday hari Khamis lah. Because of what? Based on my experience, sometimes saya tulis kat nota, and then section 8 mungkin beranggapan apa yang ada dalam section 9 adalah perkara yang sama. Tapi sometimes bila saya buat session dengan section 9, ada additional info. So additional info tu saya akan include sekali supaya kedua-duanya boleh refer satu note yang sama, and then tak ada ketinggalan. Boleh kita buat begitu for this online session. Okay, thank you. Saya berdapat 1 good, 2 good, 3, 4, 5. Oh, siap love. Love tu I am very happy. Okay, so that class please ni I want to recharge, okay, my device. Okay, please try example 1.7. We will discuss after in tutorial session. Okay, example 1.7. Okay, we stop now here. Okay, see you class. Lepas ni ada before that, I give you 10 seconds if you have any question. 10, 9.
Doktor,
Ya.
nak dapatkan PDF modul ni boleh ke doktor?
Sebenarnya PDF modul ni tak diberi tau untuk student. Masa dulu online session ada dijual kepada student, tetapi ada limitation benda This one sebab kami lecturer semua dah beli, and then sebabkan online session dia open untuk beri. Faham tak open? Maknanya nak view kan, nak conteng apa boleh. Kalau tak you all pun tak boleh. I tak sure lah untuk you view kan. Nanti I tanya, maknanya you nak beli online punya PDF.
Oh, kalau beli dia sama dengan buku hari tu kan doktor kan?
Sama je. Cuma harga dia pun masa dulu lah. Masa tu harga dia sama juga. Tapi kalau saya prefer hard copy lah. Tapi since kita buat ada ni kan, online ni kan, so saya pun nanti saya tanya kalau ada ke yang nak online version.
Tak ingat sebab nak buat yang online ni untuk rujukan, sebab yang hard copy tu dia tengah pre-order. Macam tu.
Penerbit tadi kami bincangkan juga kat Shopee tu, ada yang diorang pun tak tahu stok sebab Shopee tak ada mention stok berapa. So far kat penerbit tak ada ready stock. So that's why stok dia tulis 0. Saya pun tak tahu bila boleh dapat. Saya cuba usahakan tanya, nanti saya blast dekat group ataupun pangkat makcik ni kan kadang-kadang tengok benda lain dah teringat lain. Nanti tanya kat group
Okey doktor.
Maafkan saya. Maafkan aunty. Okay. Alright. So kita stop sini dulu. Bateri saya makin kurang-kurang dah ni. Okay?
Okey,
Boleh
okey,
doktor,
doktor.
boleh.
Boleh,
Okay,
doktor.
Okay,
bye.
doktor.
Okay. Okay, thank you.
Terima
Assalamualaikum.
kasih, doktor.
Thank you, doktor.
Doktor.
Thank you, doktor.
Thank you, doktor.
Thank you, madam.
Welcome.
Doktor, thank you.
Welcome.
Thank you.